Okay, so there are six variables that we're going to be talking that several we've been talking about, and then two new ones today. We're going to talk about the variable, what it is, and what type of units it's going to be in. So R on these problems is always going to be the radius, and the radius is always going to be in a linear unit, like inches, feet, miles, yards, whatever. Theta is going to be the angle, and there's three ways to represent angles: degrees, radians, and revolutions. And then don't forget that if it's an angle and there is no units, then it's radians. All right, S is the arc length, and it's the same units as the radius is going to be in, so centimeters, feet, linear units. All right, T is going to be time, and time can be measured tons of ways. So seconds, minutes, hours, weeks, days, years, months. Lots of ways to measure time. All right, linear velocity is going to be V. And linear velocity is always some kind of linear unit over some kind of time. So you guys are used to this, like feet per second. What does mph stand for? Miles per hour. If you don't know that, write it down. All right, and then the newest one is omega. And omega is a Greek letter that kind of looks like a butt. I don't know, that's how I remember it. And it is the angular velocity, and it's the angular unit divided by time. So degrees per second, you probably haven't really heard that, but I feel like you know RPM. What does that stand for? Revolutions per minute. So probably in your vehicle, there is I don't know, it might actually be a digital, or what's it called? Tachometer, that tells you how fast your engine is spinning. We don't want it to go too fast. But that's what RPM stands for, is revolutions per minute. All right, so this next example is harder than you would think. So we have six situations. Each of them is going to be a different variable. They're only going to be used one time. So the first one, the space shuttle makes 7 orbits of the Earth. What variable do you guys think that is? Well, if it was 7 orbits in 1 hour, it would be omega. It's theta. An orbit is the same as a revolution. So 7 revolutions is an angle. 7 orbits is an angle. All right, it's okay. The next one, I walk 10 minutes along a volcano's circular rim. What's the unit here? Yes, it's just minutes. It's just time. They give you a little extra information that you don't need. All right. A satellite is circling the Earth at 3,094 miles per hour. Velocity. Linear velocity is v. All right. A spoke of a wheel is 5.8 inches. Radius. So if it's a straight distance, it's going to be a radius. If it's a rounded distance, it's going to be s, arc length. All right. Around the world in 80 days. Around the world. One revolution in 80 days. Omega. All right, and then a circular track measures 400 feet. There's only one we haven't used. It's S, arc length. So a rounded distance is arc length. All right, so I'm going to kind of skip around a little bit. We're going to come back and talk about the angular velocity, linear velocity formula. But before we do, we're just going to do a couple examples where we're converting units. And if you have taken chemistry, you're currently in chemistry, you might be a little bit ahead of people who didn't take those courses. So I don't know, I don't feel like you have as much experience in this from your math classes as you might have from your science classes. And I do it a little differently because we are going to use these calculators that aren't very smart. And I'll get some for you guys back there in a second. that just don't hold as much information as some of the ones that you probably used in your science classes. But anyway, we're going to take 10,000 degrees and we're going to change to revolution. So this is a few examples, not all of them, of fractions we can use to convert to different units. The one we need for here isn't even on there, but we're going to take 10,000 degrees and we're going to multiply it by some fraction that's going to change degrees to revolutions. So how many degrees are in one revolution?
360.
Yes. So would I want to, since I want to cancel degrees, would I put that 360 on the top of the fraction or on the bottom? Bottom. So 360 degrees in one revolution. So because they are the same, that's like multiplying by 1. So it doesn't change the value. It just changes the units. All right. And what you would do with your little blue calculator is take 10,000 and divide it by 360. All right. And that's going to be 27.78 revolutions. Now, today, because we're using pi on a lot of these examples, we're going to round to 2 decimal places because we're just going to use 3.14 for pi. And it wouldn't be accurate to round to more because you're only using 3.14. If you guys take calculus next year, which is a really good class, we always round to at least 3 decimal places in that. So 2 is just because we're estimating pi at 2. All right, and then for B, we're going to take 20 feet per second and we're going to change to miles per hour. So I would write 20 feet per second like that fraction. All right, and then I'm going to have to use multiple fractions to get to miles per hour. So what do you guys want to do? Do you want to change distance first or do you want to change time first? It's up to you, it doesn't matter. Anybody have a preference, distance or time? Okay, let's do distance first. Now, out of all of the different things that you're going to need to memorize, that one might be the hardest. I feel like you know everything about time, inches and feet and things like that, but you might not know that there's 5,280 feet in a mile. If you're used to the metric system, this is going to be a little bit harder for you. The metric system is so much better than whatever crazy system that we use, but I need y'all to know by next Wednesday, I guess, that there's 5,280 feet in 1 mile. So where would I put feet if I want to cancel feet? On the bottom. All right, so if I did this math, I would have miles per second. But I want miles per hour. Now you might know how many seconds are in an hour. I'm going to do this one just going slower. When we move forward, I'll probably just start using the number of seconds that are in an hour. But I know everybody knows there's 60, well, hold on. There's 60 seconds in 1 minute. But if I want to cancel seconds in this situation, where would I put the second? On the top. All right, so if the seconds are on the bottom and I want to cancel them, I have to put them on the top. So now I have miles per minute, but I want miles per hour. So I'm going to cancel minutes. Where would I put the minutes? On the top. Okay. Now I'm pretty sure that the science teachers teach you on a smarter calculator, and what they say is it works. But for our calculators that aren't very smart, on a lot of these problems, what you're going to need to do is if it's in the numerator, you're going to multiply by it. And if it's in the denominator, you're going to divide by it. I think this one you could do however you wanted to. But what I would do is take 20 and then divide by 5,280 and then multiply by 60 and then multiply by 60. So on the top, you multiply, on the bottom, you divide. Everybody practice it, please. Do you have a calculator, Brady? All right, so did you guys get 13.64? And for miles per hour, you can do mph in the end, or you can do miles and then divide it by hours. Now, I know that what you probably did in chemistry is multiply across the top, multiply across the bottom, and divide. And that will work. But sometimes the number gets so big, like we're going to have to multiply 15,000 by 5,280 on example C, and it gets confused. So, all right. Now, let's talk about the formula. Would you guys have questions on this one? Okay, so there is a relationship between the angular velocity and linear velocity because when something is traveling in an arc, it has both. Where the linear velocity, which is v, is equal to the angular velocity times the radius. So I am going to set up that little t thing like we did yesterday. So for this formula, what should go on the top of the t? V. And then these two should be omega r. So we can use that to decide if you multiply or if you divide, just depending on what you want to find. All right, so on 14, we're going to use the given information to find the following in the desired units. So we have that omega is 60 revolutions per minute, and r is 2 feet, and we want to find v in feet per minute. Now to find v, we're going to multiply omega times r. When we set this up, we can't do 80 RPM. We have to do it 80 revolutions in the numerator and minutes in the denominator. Right, and then we're going to multiply that by 2 feet. Now I'm going to put 2 feet over 1. It's up to you if you do that or not. It's not necessary if you can keep it straight. Now, if I multiplied this, I would get revolution feet per minute, which doesn't really make sense. So I want just feet per minute. So if you have an angle measurement in your work, but you don't have an angle measurement in the answer, what do you change revolutions to? What type of angle doesn't have a measurement? Radians. So I want to change revolutions to radians. So where would I put the revolutions? On the bottom, because originally revolutions is on the top. And then how many radians are in one revolution? 2 pi. Okay. And then I'm just going to double check my units. What I have is feet per minute. That's what I want. Feet per minute. All right. So on these little blue calculators, for 2 pi, we're going to use 6.28. It's not a great approximation, but it's all we can do with what we have. Oh, not for pi. Sorry, for 2 pi. All right. There's no division on this one. It's just going to be 80 times 2 times 6.28. And make sure on all of your answers you write the units. All right. Any questions so far? Okay, let's look at B. So on B, we're given that V is 60 miles per hour and R is 15 inches, and we want to find omega in revolutions per minute. So if we look at our little diagram and we cover up omega, we're going to take the linear velocity and divide it by the radius. Now, on these fractions, we're not dividing, we're only multiplying. So how can I change that division problem to a multiplication problem? What's the same as dividing by r if we're multiplying? All right, we're going to multiply by the reciprocal of r. All right, so we're going to take v, which is 60 miles per hour. We're going to write it as miles per hour this way. And then we're going to multiply that by the reciprocal of the radius. All right, now this would be some crazy weird unit of miles per hour inches, which doesn't make sense. So we're going to do a whole lot of changing until we end up with revolutions per minute. All right, so I don't like having these two linear units. So I'm going to change miles to inches. I do not know how many miles are in an inch. I don't want to know. So what I'm going to do is just take baby steps, and I'm going to change inches to feet. Where should I put the inches? On the top. So I know there's 12 inches in 1 foot, and that will cancel my inches. All right, and then I can use one fraction to cancel the miles and the feet. So since feet is on the bottom, I'm going to put feet on the top and miles on the bottom. So I know there's 5,280 feet in 1 mile. Okay. So I need to change hours to minutes. Since hours on the bottom, I'm going to put number of hours on the top and minutes on the bottom. So if I did all the work here, what would my unit be? It's a omega. What would the units be? What? Radians per minute. Very good. But what we want is revolutions per minute. So where would I want to put the revolutions? Revolutions in the top. So revolutions per minute means revolutions on the top, minutes on the bottom. So 1 revolution. And what do you guys think about the bottom? 2.5. Good. All right, everybody practice this one. It's a lot going on. So what we're going to do, I do not like that. We are going to take 60, and then we're going to divide it by 15, multiply by 12, multiply by 5,280, divide by 60, divide by 6.28. Now, our quiz over this is going to be the middle of next week, and I highly recommend that you write all this out because it's just really easy to do all the work right and just type something wrong in the calculator, especially with these calculators where the buttons are so small. So you'll get lots of credit for getting this part right for sure. Okay, let's look at C. So C, we know that omega is 1,000 revolutions per second, and V is 15,000 miles per hour. I have no idea what's going on with this problem, but it's fast. We want to find R in inches. So what do we do to find R? Right. Divide linear velocity by angular velocity, or take V and multiply it by the reciprocal of omega. All right. Now we got lots of stuff going on that we don't need. We don't want a time. We don't want an angle. And we want our miles to turn into inches. So we have several fractions we have to go through today or on this problem. All right, so let's just get rid of this time first. So 1 hour is 3,600 seconds. Now, if you don't want to mess with remembering that, you can do two fractions. You can change hours to minutes and minutes to seconds if you want to, but I don't think it's too hard to remember that there's 3,600 seconds in an hour. It's just 60 times 60, right? All right, so that takes care of those. All right, we want no angles. So I want to cancel revolutions. Anytime I want no angles, I'm changing it to radians. Okay. And then I need to get rid of the miles. So I'm going to do it in two steps. I'm going to change miles to feet. And then change feet to inches. All right, this is the one that overloads the calculator if you try to multiply across the top and the bottom and divide. We probably could cancel out some zeros though. All right, so I got the same thing I got earlier, so I think that's a pretty good sign. All right, these last few examples are application problems where it doesn't straight tell you this is omega, this is V, this is R. You have to kind of figure it out. So just remember, omega is always going to be an angle per time, and V is always going to be a distance per time. So they can be hard to keep straight. So on 15, a bicycle wheel has a 30-inch diameter. Do we want diameter? No. So I'm just going to go ahead and say that there's a 15-inch radius. If the wheel makes 1.5 revolutions per second, find the speed of the bike in miles per hour. So this 1.5 revolutions per second, what variable is that? Omega. And what we're finding miles per hour is V. So when I'm finding V, I'm multiplying omega times R. But that's just the beginning. All the work from here on is just changing whatever this is, revolution inches per second, to miles per hour. So I'm just going to go ahead and get rid of my revolutions because I don't have any angles in V. Do you guys have a preference about doing time first or doing distance first? Time first? Okay. I'm going to hours, and I know there's 3,600 seconds in 1 hour. Right. And then finally, I need to get to miles. So I'm going to change inches to feet to cancel inches. So inches was on the bottom. And then go feet to miles. And then I'm just going to double check my units. So I have miles in the numerator, which is where I want it, and hours in the denominator. So we should be good to go. Shoot. Messed up. I was gonna have to start over. I don't like it. So when I did this earlier, I got 8.03 miles per hour. Is that what y'all got? Those of you that did it? Okay. Okay, a couple more. Right. This is one of the reasons I'd never be an astronaut or a test pilot. There's lots of reasons, but a centrifuge has test pilots traveling in a circular path very quickly in order to experience G forces. If the pilots are traveling 400 miles per hour in a circular room, and the circular room has a radius of 25 feet, find the number of rotations that the centrifuge makes per second. It's very, very fast. What we are finding omega, absolutely. Rotations per second is basically revolutions per second. And we have this miles per hour is V. And obviously it tells you straight up the radius is 25. All right. When we are finding omega, we're going to take V and we're going to multiply it by the reciprocal of R. And then we want to end up with rotations or revolutions per second. All right, so I'm going to go ahead and just get rid of these linear units that I don't need. So because mile was on the top, I'm going to put it on the bottom. And feet are on the bottom, so I'm going to put it on the top. And that takes care of those. All right, and then my time unit, I want to be seconds. And so right now, this is radians per second, and I want to change it to revolutions. So I'm going to insert revolutions on the top. Okay. So 400 divided by 25 multiplied by 5,280 divided by 3,600 divided by 6.28. And that's going to be 3.74 rotations per second, or revolutions. It's pretty fast. One more. So a second hand has a large clock. Sorry, the second hand of a large clock is traveling at 2.5 inches per second. That is going to be, you guys tell me, what is that going to be? Inches per second. V. We want to find the length of the second hand. So we want to find R. When we're finding R, we're going to take V and multiply it by the reciprocal of omega. Do we have an omega for the second hand? Do we know how clocks work? Some of us do. How fast does a second hand go around an angular velocity? So 1 revolution in 60 seconds? Or we could say 360 degrees in 60 seconds. What else could we say that would be the best for this problem? 2 pi in 60 seconds. All of those would work. 1 revolution, we could do it using that and then get rid of revolutions. Or 360 degrees, we could do that and get rid of degrees. But if we do this one, we're not going to have to do any extra steps. So what we'll do is take our 2.5 inches per second and multiply it by the reciprocal of our omega. And seconds cancel out. The only unit I have is inches, and that's a perfectly acceptable unit for radius. It didn't tell us what to leave it in, so we're going to leave it in inches. So it is just 2.5 times 60 divided by 6.28. And it's a pretty large clock, almost a 2-foot second hand. All right, so what questions do you guys have? All right, so the last assignment in the packet is on page 7. It says 1 through 4, but there's A, B, C, D on part of it. So it's several problems for you guys to do.